Hello everyone, we hope all of you are doing well and taking enough protective measures to keep yourself protected and safe against COVID-19. Our today's demonstration topic is experiment number 9, that is the last experiment of EE306. In this experiment we will study the torque speed characteristics of three-phase induction motor. Today we have two objectives. Our first objective is to evaluate the performance and the efficiency of the loaded motor. And our second objective is to determine the torque speed characteristics of that loaded induction motor. Now let's see the major component of our today's experiment. As you can see from the figure, in the right side we have the induction motor and in the left side we have the connected mechanical load. That mechanical load will be controlled from this control unit, as you can see at the top of this figure. This is the zoomed image of the front panel of the induction motor. Like previous experiment, we have to read the nameplate data of the induction motor. As you can see from the figure, there is an sticker at the top of the induction motor. And from that sticker, you can read the nameplate data of this induction motor. From the nameplate, you can record most of the required data. For other required data like synchronous speed and nominal torque, you have to calculate them using these formulas. For your information, the number of poles of our induction motor is 4 and our system frequency is 60 Hz. Here is the circuit diagram of our today's experiment. As you can see in the left side we have the control unit. From the control unit we will be applying mechanical load to the induction motor. We have to take care of two things for our today's experiment. Number one, the current should not exceed 2.2 ampere and the torque should not exceed 5.58 Newton meter, as these are the rated value of the induction motor. After making the circuit connections, we will do the required measurements in KC software.
This is about a three-phase induction machine, which is going to carry a torque, and this torque is represented here by the magnetic brake, and then the control of the torque is at this level. So it's very similar to what we did in the load torque characteristic of a DC machine. So we're doing something similar for the induction machine. It's a three-phase, it's an AC three-phase machine that's carrying a load. Now we are going to try to vary the torque at different steps, and we will have to plot the different characteristics as you see it here in CASI file, where the torque is being applied, varying from 0 to almost like 5 Newton meter. And you see the impact at the speed, the impact at the drawn current out of the source, and then you see the voltage, the input voltage is steady because that's the supply voltage. Great. Now this is going to be very useful in defining the characteristic of the motor, its capability, and its speed interaction with the load. So it's going to depend on the application in the industry, and that application will define the suitability of the motor to a certain application, or you probably need to go for a higher rating. This machine is supposed to be a machine that's capable to carry a power of 1 kilowatt, and then accordingly the load has to be sized. Good. So this is supposed to be the last experiment in this course, in this series of labs. So you're going to have to go through the report and then go through the steps of the reports, 1, 2, 3, 4, and then fill the table. The normalized quantity at the end, you have to think about it, how to do it, and then you have to check the efficiency of the motor. So your task is to fill the remaining data and then proceed with the report. Our reporting is going to be as usual, send it by PDF or email, and then it's going to be graded. So that's it.
As a requirement of the report, you have to provide the recorded and calculated data in Table 2. As you can see, all the mentioned items have already been recorded in the KC software except the efficiency. Now you have to define the efficiency formula in the KC software to calculate it. In table 3, you have to provide the normalized data. To get the normalized data, you have to divide the mentioned items by their rated values. For example, to get the normalized speed, you have to divide the speed by the rated speed of the induction motor, which is 1710 RPM.